Okay, so here we are back at this problem. We're actually ready to code this thing, and so we're essentially going to implement first do this box right here, and a couple things I need to do on this are, what do I need to do? I need to make an accumulator and start it at 0. And so x20 is where the problem wanted the answer, so I'm going to start that accumulator at 0. Second thing I need to do on this one, I'm thinking I need some copies of this thing, so I'm going to go ahead and move, let's see, is x10, now I made 2 copies of x10, and so I'm going to go ahead and use those in the program, and I could also actually have, I have to do 3 nibbles, and now I have 3 values, x10, x11, and x12. Last thing I need here is I need some masks, so I'm going to say x25, 0x, 0, 0, 0, 0, 0, f, 0, 0, load immediate x, 26, 0x, 0, 0, 0, 0, 0, f, 0, load x, 27, 0x, 0, 0, 0, 0, 0, 0, 0, f. Those are my 3 nibble masks, and you'll see how I'm going to use those in a minute. And I think that's good enough. I think we're done with initialization. So the next thing here is we're at this flow chart here, and what we need to do is implement this thing. And so we'll give it a cool name, do hundreds here. I'm at the adjust portion of this thing, and so what I'm going to do here is grab one of these values. I'll go ahead and do x12. I need to mask it, and x12, and we'll take the hundreds mask, which is x25. Okay, so that means I masked all the bits except this one. All the bits except this 4 bits, or this nibble, is now 0. Once I do that, I'm going to shift that over 8, shift right, logical immediate, x12, x12, 8, and at that point I'm done with adjust, and I'm ready to start the while loop. So it's a very straightforward while loop. B, E, branch, if equal to 0, and what I'm going to say, x112, x10, and I'm going to branch to do tens. And once I do that, I'm going to come down here and say do tens. I always put the label in when I write a label. So that's this thing. So if this condition fails, that means the value is 0. I have nothing to add. So I'm going to come down here. If the condition, essentially if that condition is true, I have nothing to add. I come down here. If the condition fails, that means there's a value in that right nibble here, and what I'm going to do is add immediate to my accumulator, x20, 100. Okay, so that's my add. I'm a decrement, add immediate x12 minus 1, and then I'm going to jump, jump to do 100. Okay, so that implements this algorithm right here that handles the hundreds case. So once again, to summarize this, I took the value, I isolated that value, I shifted it right to 8, and so that value, the hundreds value, is now in the 4 lowest bits, and I started adding 100 for each time that value was not 0. So each time through that loop, I'm adding 100, and I'm subtracting 1 from the loop count, which happens to be that value, and then I'm going to jump back and do it again. So this is a classic while loop structure. Technically speaking, I don't know how many times I need to do it, but it doesn't really matter. It's going to take care of itself, because if I don't have to do it any time, it's just not going to go through the body of the loop, which is why a while loop works so good. Okay, so that's nice. I'm going to go ahead and move this down a little bit, just to give myself some space. Do tens. Okay, so now the algorithm for the tens is very much like, it's the same algorithm as I used up here, so I'm just going to copy that code down pretty much as fast as I can. I have to use another register. I'll go ahead and use X11, and I need to use the other mask, which I got in X26, which it's going to isolate that nibble this time. Okay, so I'm going to shift it right. Logical X11. I'm going to shift it right by 4. It's in this position. I need it in this position. And then I'm going to do the same idea. X11, X0, and I'm going to say do ones. And so I can come down here and do ones. And this is going to be very much like this. I'm just still copying it. Add immediate X20, which is my accumulator. X20. I'm adding to it, not 100. I'm adding 10. I'm decrementing the count. Add immediate X11. X11 minus 1. And then I'm going to jump to do tens. Sorry about that. And I got to move this label. Okay, so this is the same algorithm, works for the tens rather than the hundreds. And by the time I'm done here, I just need to do the ones. I don't have to do that algorithm, but I do have to mask it. So I'll do the do ones. I'm going to and. I'm running out of space here. And X10, put X10 with the other mask, which is X27, which is this mask, isolates the lower nibble there. I'm going ahead and add that thing, X20, the result of that operation there, which is X10, and then I am going to call it done. Here's my return. Kind of ran out of space there. So essentially, that's it. That's the entire program. It looks like a hell of a lot of code, and it's like, oh my god, what's this code? But if you break it down into sections and constructs, it looks very doable. So this was our main algorithm, high level. We dropped it down to this little flowchart that we operate on the hundreds and the tens. That wound up as a big chunk of initialization code up here. Then we had the first algorithm for the hundreds, second algorithm for the tens, which were both while loops, and this was more sequence statements down here, and that is my total solution on this. And what's interesting here is I know I didn't do it the same as this one. I mean, there's so many ways to do this problem that, you know, they're all going to work. I actually, even as I was doing this, I could think of better ways to do it. Better as in less instructions. Maybe not as simple, but less instructions. So there are multiple solutions. Typically, when you submit something to me, I look at the solutions really carefully. Don't look for that one solution. Typically in these solutions, don't try to make it super great and super efficient. My motto is always get it done and then go back and get it done good. Okay, so mostly in this class we only have time to get things done. If we had extra time, we could go back and get them done good. So in summary, very advanced problem, but it's actually a good problem because it actually did something meaningful, something you can relate to, and then it showed you just the power of assembly language programming. Certainly showed you some nice while loop constructs. The program itself was just a combination of the while loop constructs. And actually, looking at the solution, I noticed I did something wrong, so let's go repair this solution. So this is wrong. I'm not jumping there, I'm jumping here. Now it jumps to, I can't jump back to here since this is kind of my initialization portion, and that's the mistake I made in the other one. So this one has the same issue here. I'm not jumping to this label, I'm jumping to this loop label here. Okay, and it was going so good too. Anyway, I'm glad I looked. Sorry about that.